Hello students, today we'll discuss coordinate geometry questions. This is a calculator set. Let's begin. Question 1. In the xy plane, the line from the origin to the point 12, 16 passes through the center of the circle given by x minus 6 whole squared plus y minus 8 whole squared is equal to 25. Okay, if a buck starts from the origin and goes in a straight line to A, then moves along the curved path from A to B, and finally reaches the point 12, 16 from B in a straight line, what distance has the buck covered? Okay, so what they're basically saying is that there is this circle, right, with center at 6, 8 and radius 5, right? Because in a circle, x minus h whole squared plus y minus k whole squared is equal to r squared. The center is given by h comma k, which in this case is 6, 8. And the radius is given by r, which in this case would be 5, since the right-hand side is r squared, 25. Now, they're saying that if this was a straight line, it would have passed through the center of the circle, right? Which means that AB would be the diameter of the circle, and that would be 10. But the bug that is going from the origin has decided to go like this and take the curved path. It could take either curved path because they'll both be equal, right? This would be a semicircle and this would also be a semicircle. So let's say it takes this curved path and then it goes till here. So what is the distance it covers? So let's say that the bug, let's call this origin O, and let's call this point D. Let's say the bug went in a straight line, OD, without taking the curve. Suppose it went through the circle in a straight line. Then what would OD be? OD would be square root of 12 minus 0 whole squared plus 16 minus 0 whole squared. This is the distance formula. And that would be square root of 144 plus 256, which is square root of 400, which is 20. So if it had gone straight from O to D through the circle, it would have traveled 20. But it actually did not, right? It only went to OA, and then it took the curved path and then went to BD. So then I can say that OA plus BD would be OD minus AB, which would be 20 minus 10, which is 10. So the sum of OA and BD is 10. Now we simply have to find the curved path, and that would give us the total distance the buck traveled. So the curved path is the semi-circumference, right? Because it's half a circle. So the semi-circumference would be pi r. And since the radius of the circle is 5, it would be 5 pi. So the total distance that the buck covered is 10 plus 5 pi, which is option C. Question 2. A point P is selected at random from the interior of the pentagon with vertices. So let's draw this pentagon. 0, 2. So let's say this is A. Let me redraw this. 0, 2. Yeah. B, 4, 0. C 2 pi plus 1 comma 0. 2 pi plus 1 will be about 7, close to 7. So let's take this as C 2 pi plus 1 comma 0. D 2 pi, let's take this as D 2 pi plus 1 comma 4, right? And 0 comma 4. Okay. So this is how my pentagon would look. A, B, C, 1 second. Yeah. And all of these are perpendicular, right? Because this is a straight line, this is a vertical line. So this is perpendicular, this is perpendicular, right? Okay. So now a semicircle is drawn inside the pentagon with AB as diameter. Okay. So we have a semicircle like this with AB as diameter. What is the probability that P lies inside the semicircle? Okay, so basically this is the required probability would be area of the semicircle divided by area of the pentagon, right? Because if P is a point inside the pentagon, the probability that P lies within the semicircle will be area of the semicircle divided by area of the pentagon. So actually this is very simple because what is the distance AB? AB is basically the hypotenuse of a right triangle with sides 2 and 4. So AB would be the square root of 2 square, which is 4, plus 4 square, which is 16. So that square root of 20, which is 2 root 5. So AB is the diameter. So the radius of that semicircle will be root 5. And the area of the semicircle would be pi r squared by 2, which is pi into 5 by 2, or 5 pi by 2. So that is the area of the semicircle, right? So that is 5 pi by 2. Okay. Now what is the area of the pentagon? The area of the pentagon will simply be, let's say this is O, then the rectangle OEDC minus the triangle OAB, right? That's what it will be. Because if you look at the rectangle OEDC, and then you have the triangle, this triangle. So if you subtract them, you get the area of the pentagon. So OEDC would be 4 multiplied by 2 pi plus 1, right? Because 4 is the height of the rectangle and 2 pi plus 1 is the base, minus half times 2 into 4. Because 2 into 4, that's the base and the height of the triangle. So that becomes 8 pi plus 4 minus 4, and that's just 8 pi. So the area of the pentagon is 8 pi, and the area of the semicircle is 5 pi by 2. So my probability will be 5 pi by 2 divided by 8 pi, which is 5 by 16, option C.